All right, welcome back. We're continuing a video lecture series on chapter 2.1, which is about descriptive statistics, specifically for categorical variables. So in this video, we're going to look at how to analyze, summarize, and display two categorical variables at the same time. So we're going to look at relationship between two categorical variables. So let's just go with an example to start off. Suppose we have data collected from university students on two variables, their relationship status and gender. So probably the most common way to visualize and display this type of data is a two-way table. So in a two-way table, we're showing two different variables. The columns represent the gender variable, male versus female, and then the row variable is the relationship status. Notice it doesn't matter which variable is displayed. So we could take the transpose here and put male, female as columns and relationship status as rows. It does not matter which one is which. And the total row and column are not always shown, but it's generally, I would say it's good to kind of show those columns. Okay, how many are total in each relationship, complicated, single, and then how many males versus females took part of the survey, and then looking at the total that took part of the survey. Okay, so I want to go through a couple questions looking at this table. What proportion of students in this sample are in a relationship? I encourage you to pause and see if you can get the correct answer. And the answer to this is 42 out of 169. So we're looking at what proportion of students in the sample are in a relationship. I just need all those 42 over 169. Now what I'm going to do is give a little bit more explanation. Kind of connecting this with the probability chapter. I have the table written here, but now I've given probability variables: R for relationship, C for complicated, S for single, F female, M male. So for that first question, what proportion of students in the sample are in a relationship? We could also write that P of R, looking at that probability notation. And that would be the 42 divided by 169 to get that value. All right, the second question: what proportion of females in the sample are in a relationship? All right, again, I encourage you to pause and see if you can get the correct answer. All right, and drum roll, please. The answer is 32 out of 107. All right, so I want to go over to the other document to write some more stuff out about this problem. But one way to approach this is what proportion of females. You're only looking at the females, so the first column right here. Of all the 107 females, how many of them are in a relationship? And that would be 32. But I want to connect that, so answer B, with some probability notation. So we would write that, if I want to write that to probability notation, that would be probability of relationship if female. So we're looking right here, we're only looking at of the females, given females, only the females, how many of them are in a relationship. And the formula, if you remember for this, is the probability of relationship and females divided by the probability of females. So this is the formula from the probability section. It still works here. I think this is maybe more convoluted than you want. But how many, or what's the probability of being in a relationship and female? That's 32 over 169. And then how many the probability of being female? That is 107. Parentheses. 107 over 169. And if you were to multiply by the reciprocal of the denominator, you would get that 32 over 107. That's what we had before. So I'm showing you this to see that the formula from probability section still works. But if you see a question like this in homework or an exam, it's very okay if you could just read this table and say, oh, of females. I would highlight that or underline that and say, oh, of the females, that's why the denominator is 1 of 7. All right, what proportion of people in a relationship in the sample are female? All right, hopefully you got a guess, or you think your answer is correct. 32 out of 42. So again, I'm going to go back to that document and type this up in terms of the probability notation, but I don't think you need to do that. We're looking at the portion of people in a relationship. So all the people in a relationship, now I'm only concerned with this first column, the in relationship, in this first row, this in a relationship row. There's 42 total in a relationship, and now how many of them are female? That's 32 out of 42. So notice the answer to the last problem has the same numerator, but a different denominator. So in this one, I would say of people in a relationship. That's kind of the key word here. So of the people in a relationship, that's the denominator we want to look at. But we could use that probability notation. Here we're looking at probability of female if in a relationship. So notice the notation is almost the same, except we swap the R and the F, and that can make a huge difference. That's the probability of F and R divided by the probability of R. Notice here the only difference between these two is the denominator. And instead of writing the fractions, I'm just going to write the total number because the 169 is going to cancel out. I can think about this as how many are female and in a relationship. That's 32. But now how many in the bottom are in a relationship? That's just 42. So denominators are the same. Excuse me, the numerators are the same, the top of the fraction, but the denominators are very different. You get two very different answers here. So that's why I put a caution on the next slide. The proportion of females in a relationship is not the same as the proportion of people in a relationship who are females. Easy to get these mixed up. And if you turn those percentages, they're actually quite different, 30% versus 76%. So be careful about the conditional part of the statement. All right, let's do one more of these from this table. What proportion of males in the sample are in a relationship? Feel free to pause and see if you can get the correct answer. And here we should get part C, 10 out of 62. Think about that. Of males is the key word. Looking at just the males in the group, there are 62 total. That's my denominator. And of those males, how many are in a relationship? 10. So we get 10 out of 62. And just to make some room, I'm going to delete all of these. All right, so what proportion of males? Again, that's, I think, the key word here. I would underline or highlight or taking a test or doing a homework assignment. Okay, of the males, that's the given. So relationship if male. And we do the same exact setup, R and M. And we're divided by the probability that someone is male in this survey. So we can write that out. How many of them are in a relationship and male? That's the 10. And then we can just take the total number that are male in the survey, 42. Oh, excuse me, 62. Get that correct. 10 out of 62. All right, so kind of interesting thing to look at. This was a real survey done. It was a while ago, but real data. 30% of females in the sample say they're in a relationship. But only 16% of males in the sample say they're in a relationship. Why the difference, do you think? Well, I want you to think about why could there possibly be a difference. And this is one of the video lesson questions. So no right or wrong answer. Just want you to think about this for a couple minutes and think why would there be a difference? Why wouldn't these be the same or close? Maybe not the exact same, but why are they so off? Okay, so that leads us to difference in proportion. We're going to be studying this idea, okay, looking at two different populations or two different subgroups of a population and see if there's a difference in proportion between these two groups. And here's a definition: difference in proportion for one categorical variable calculated for different levels of the other categorical variable. And as an example from the previous survey, proportion of females in a relationship versus or compared to or difference of proportion of males in a relationship. So notationally, if I want to write this data, there's that p hat again. P hat f minus p hat m. I remember it was 30% of females said they're in a relationship, 60% of males, so the difference is 14%. So oftentimes you don't actually care about the actual value, you just want to know what's the difference, how far apart are the two groups in their proportions. So don't forget, just as a reminder, we use this hat notation when we're dealing with samples, p hat for samples. Subscripts are often used when we have two groups. You could just use p hat 1 and p hat 2, which we'll do often in this class. But I like the convention of using the variable name, so it makes sense. So it's easier to read. P hat f, okay, that's proportion of female. P hat m, proportion male. And one other thing is you can change these. It doesn't actually matter which way you subtract the two differences. But as a rule of thumb, I would encourage you, and I'm trying to stick mostly with always picking the bigger number first, the bigger proportion first. Just it's easier to read. As humans, we have to kind of translate those negative numbers. So it'd be better to put the 0.3 minus the 0.16 to say, oh, there's a 14% difference. Females have a higher rate of saying their relationship than males. Okay, so let's look right here. One more example in this video. P hat r, we're going to define as a proportion of students in a relationship who are female. P hat s is the proportion of single students who are female. I can encourage you to, if you want, pause the video, see if you can write down those proportions and calculate the answer. All right. First thing to think about is what's the proportion of students in a relationship who are female. So there's the students in a relationship. I'm only looking at this 42, and how many of them are female? This 32. So that p hat r is 32 over 42, minus p hat s, proportion of single students who are female. So if we take of the single students, that's 108. How many of them are female? 63. That's why it's 63 over 108. Throw these in your calculator, you get a difference of about 18%. All right, a couple other ways to visualize two categorical variables is a side-by-side bar chart. So here, notice we have frequency here on the left column, the vertical axis, and the height of each bar is the number of corresponding cell in the two-way table. And there should be some kind of key. The darker rectangles, are the female group, and then the lighter color is the male group. So here we have the in relationship, it's complicated and single. I think less common, but you might see on occasion, is a segmented bar graph. It's like a side-by-side bar graph, but the bars are stacked. So we're just doing a total here instead of side-by-side. I have to be honest, I generally think it's better and easier to read information on the side-by-side than the segmented or stacked, but you might see these graphs as well. All right, I got one more example to go over from this section, but we'll do that in the next video.